Hello and welcome to another tutorial. We are going to continue on discussion of the how to create objects, which are basically instances of a particular type or class. Now we saw that we first use the new operator, and then after that instantiation happens. The new keyword is a Java operator. Remember, usually for new, we don't say new is a Java keyword. It's when you use, for example, an ID, obviously it highlights it just like a keyword. But new is in fact an operator, and the same idea comes, basically new in Java comes from the idea of the new operator in C++. Unlike C++ that you can overload the new operator, in Java you cannot. So because you rely on JVM, if you could overload the new operator, then it could have messed up the JVM's behavior, right? And we don't want that. In C++, even for a particular class, you can overload the new operator, so that for that particular type, the memory allocation and initialization happens exactly the way you want it. But the whole idea of new is you want to allocate some memory for this particular type, right? A class is a type, it holds some data, which means a state. So it requires some amount of memory to hold those data. And we already know the type of the data, right? The type of fields that this type has. So basically, when we call the new on a type, it means we want to allocate memory and then initialize the state of that particular object or that amount of memory that was allocated based on the parameters that we passed to the constructor, right? Instantiation, the new keyword, is a Java operator that creates the object, which means it allocates the memory, and we already saw the bytecode, which basically calls the new operator in the bytecode, and it's just it just allocates memory. And then after that, initialization, the new operator is followed by a call to a constructor, which initializes the new object. And we saw that in the constructor, a couple of things happen behind the scenes. One is the first line of the constructor is always a call to the superclass constructor. After that, the second line is always all the instance initialization. You might or might not have explicitly defined any instance initialization. After that, the rest of the code that you put in the constructor, right? So in order to create an object of a type, first the state of the superclass of that type has to be initialized, right? That's one of the strict rules of object-oriented programming. Whenever you inherit something from some class and you're trying to instantiate that type, the superclass has to be initialized, because the state of the superclass is actually part of the state of the subclass. And we saw that Java provides access modifiers, which means you can restrict which part of the state of the superclass the subclass can directly access and change, and which parts are private to the superclass. We saw that when you use the keyword private on some particular fields of an object, it means you want the state to be just for that particular type. No other type, not even a subclass, can directly access that state and change it, right? So even though you always inherit the total state of the superclass, then you might not be allowed, the subclass might not be allowed to change or mutate part of the state of the superclass. That's the whole business of the access modifiers. Declaring a variable to refer to an object, and we said that these are called reference types, and these are handicapped pointers. Handicapped pointers means behind the scenes, JVM obviously treat these as pointers, and the reason I call them handicapped pointers, basically references in Java are handicapped pointers, because the way they have been implemented in Java, you don't have many capabilities that the pointers provide, for example, in C++. So references in Java are just handicap pointers, and the reason that they had to come up with reference types was because Java is a statically typed language. So when you call the new operator on a type and create an instance, you want to have a pointer to it so that you can always reach out and grab the data or the state of this object, right? And instead of saying point a star, which was a pointer type, they decided to drop the star so that the syntax looks cleaner, nicer, simpler. But then you can, there is no such thing as dereferencing a pointer or pass by pointer, right? These things are not allowed in Java. In Java, everything is passed by value, etc. Previously, you learned that to declare a variable, you write the type and the name, and the reason you have to specify the type just because Java is a statically typed language. This notifies the compiler that you will use name to refer to data whose type is type, right? This type. With a primitive variable, this declaration also reserves the proper amount of memory for the variable. So when you say int name, it means we're declaring a variable of type int, right? The name is name, and it hasn't, we declare it, but we haven't initialized it, right? So it's uninitialized. You can also declare a reference variable. So in Java language, we don't really call them pointers. We could call them handicap pointers, but in Java, they just call them reference variables. On its own line, for example, point origin. So we are declaring, and if this is a field, we saw that the local variables don't get any default value. They are uninitialized, right? And the compiler won't allow you to use a local variable that is uninitialized. Unlike C++, that if a variable hasn't been initialized, it already has some garbage value, and the compiler doesn't give you a compilation error if you use it without initializing. But in Java, if a local variable, even if it's a reference type, it hasn't been initialized, so you're not allowed to use it. If it's a field of a class, it gets the default value. We know that the pointer, the default value of a type is when all the bits are 0. And for a pointer or reference type, it means it's null pointer or null reference. In C++, they added the null pointer keyword. In C, we had the null, N-U-L-L, which was just 0. In Java, we have the null keyword, Null. If you declare origin 1 like this, for example, its value will be undetermined. I mean, if it's a local variable, it's not initialized until an object is actually created and assigned to it. Simply declaring a reference variable does not create an object, which makes sense because this has nothing to do with object. Object creation happens when you use the new operator. So when you say point origin 1, for example, you're declaring a variable of this type, no object creation happens, right? Because new has to be explicitly called in Java, and the default, and then the constructor, one of the constructors then has to be called. So it's the new operator that allocates the memory in Java. There's only one way to create objects of Java. So in C++, there are very kind of different ways to create objects. You can create on the stack, you can create on the heap. So in C++, in fact, writing a line like this, point origin 1, it actually creates an object on the stack, and it calls the default constructor of this object. I will show you the example exactly how this works in C++. But again, in Java, they went for simplicity and uniformity in the way that you want to only have one way of creating objects, and that's the new operator. For that, you need to use the new operator as described in the next section. And again, you are not allowed in Java to overload the new operator. So memory allocation, initialization, everything has to happen behind the scenes with the JVM. That's the whole point of having a virtual machine, a JVM. Then everybody just relies on JVM, and the people who develop JVM, they're just constantly improving it, making it more efficient, right? You must assign an object to this variable by basically using the new operator before you use it in your code. Otherwise, you will get a compiler error, right? A variable in this state currently references no objects. And again, if it's a local variable, it's uninitialized. If it's a field, it will be initialized to null. So let's go ahead and demonstrate this. So let's say I have this class, and then let's maybe here. So we had this type example class. It's basically some empty class that we defined here. Let's call this C3. At the moment, we have a duplicate, so we already have C3. Let's say C4. So this is just a we already have C4. Okay, we already have C4. Let's use C5. So this is a declaration of a variable. What this means, we're just telling the compiler that C5 is of this type, right? We're just saying that this, but then this hasn't been initialized. Right now, I'm getting a compiler warning that, hey, the value of local variable is not used, right? This is one of the warnings, but even before using this, we have to first initialize it. Right now, C5 is a local variable, which is uninitialized. And we said that there is a reason that the JVM doesn't initialize local variables. Unlike fields, if you have a field, it will be getting initialized. So if I go ahead and try to use it, let's say sysout C5, this calls the toString method on this object, and I immediately get a compiler error. saying that you never initialize it. The local variable may have not been initialized. Now, I can initialize to null. Remember, there's a difference between not initializing or initializing to null. And again, null is a keyword, right? So in Java, we have the null keyword. Let's put it in double quotes, null keyword. In C++, 11 and later, they added the null PTR, I believe. I think it has 2L. And then before that in C++ or C, we have the NULL capital macro. So if you include any header file, it just automatically has something automatically includes its null. And this null, again, it's the whole idea of null is that basically it's zero initializing a pointer type or a reference type, right? We said that default value of any type is when all bits are 0 in the memory. Because whenever you declare a variable with some type, the compiler knows how much the size of that memory is that this variable is going to allocate, right? And the default value, if you say allocate, initialize with a default value. For a pointer type or a reference type, it's a null. So the compiler knows how many bits this variable is going to allocate or require, and then it sets all those bits to 0. Same with int, with line, with double float, doesn't matter. I mean, memory is memory. The way that the program or the runtime or a compiler interprets those bits are different, right? That's for humans or whatever. For a machine, it's just memory, and memory, all the bits are 0, which means that variable with whatever type it is, it's default initialized. For the reference types or pointer types, the default is null. In Java, modern C++, let's call this C++ later, 11 or later, is called the modern C++. It's null PTR. They added as a keyword. And then you don't really need to add a header file or something. But then you still have access to this null macro, and this null macro based on your platform, and whether it's a 32-bit or 64-bit, it's either 0 int or 0 line, right? So it depends on platform. Null PTR keyword, it already knows what the platform is, so it's going to be more basically compatible across different platforms. Although these days everything is 64-bit, so we always build the C++ application with a 64-bit compiler. In Java, everything happens behind the scenes, so you don't care if the JVM is launching with a 32-bit addressing or 64-bit addressing. You just know that it's going to work, right? In Java, everything has been simplified for you by removing your power, right? Because whenever in C++, the developer is given a lot of power, and with great power comes great responsibility. But then once you are in Java, once you are stripped away from all those power, then everything becomes simpler and you have less responsibility, right? The less power you are given as the developer, the less responsibility also you have. So it's a trade-off depending on whether you want to stick with less responsibility and focus on more important things, or you want to focus more on the this kind of low-level stuff. So null initializing a reference type is different from not initializing it. That's the point that I want to make here. When I declare this C5 as this, I'm just declaring it, and right now it's not initialized, which means if a variable is not, and if a local variable is not initialized, the compiler won't allow me to use it. That's one of the safety things in Java. But I can initialize it with null. Remember, equaling to null is different from not initializing it. Right now, this variable reference type, which is local variable, is null initialized, or it's initialized to null. So the compiler doesn't complain about not uninitialized variable because it's already initialized. All the bits in the memory are 0. And obviously, this variable resides on the stack frame. So, and it's going to occupy 1 or 2 slots of the stack, because a stack is always 32-bit, but reference types could be 32-bit or 64-bit depending on how the JVM is launched, whether it's in the 32-bit addressing or 64-bit addressing. But if I run this, obviously the compilation works fine, but I'm going to get a runtime exception, which means it's null pointer exception. However, null, they have added the capability of converting null to a string. So null keyword can be converted to a string. And this is a good thing. Otherwise, you just the amount of occasions where you get null pointer exception just increases, and it becomes a little bit more annoying. So they added this capability that, hey, if we pass an object that is referencing null, it's just null initialized, let's still print it. So let's go back into this print that takes an object. It checks the a string value of x, so it immediately converts this s to a string. Let's look at this, and yeah, so as you can see, this comes from the string class, and whenever you try to use this static factory method value of to convert an object, obviously it has a null check, and therefore that's why this print line in the print string class also doesn't complain about null, or it doesn't throw a null pointer exception. If you don't add this null check, then if this line of code passing a reference that is null initialized will throw a null pointer exception, which is very annoying, right? So another thing that you can always compare a reference type against null, which means you can say sysout, for example, c5 equal null. So reference equality means we are comparing the memory addresses. Obviously null doesn't have a memory address, so this is a special thing. Again, in the compiler and the JVM both understand what this means. It just checks whether c5 has been initialized to null or not, and returns true, right? If I don't initialize, of course, null initialization also doesn't this comparison also doesn't work. I still get a compiler error because that's a strict rule. Any local variable has to be initialized to something before using, even initialized to null, which only works for reference types or pointer types. All right, and then this works true, right? Now the case for the fields are a little bit different, which means if I have a field of this type, let's call it C6, right? This when the JVM basically loads this class into memory, or basically when JVM creates an instance of this class, then this field is going to be initialized to null, right, of this class. Then all fields are default initialized, which this means that C6 right now in our code, in source code, it looks like C6 is not initialized. But one of the safety guard or safety procedures in Java is that C6 will be initialized to null. And again, there is a difference between not initializing a reference type or initializing it to null. The compiler makes the distinction. So we can obviously one practice, some people say that maybe it's always best practice to default initialize, explicitly initialize to null, but that's not necessary for the fields because the JVM will do it for you behind the scenes. And obviously I can prove this by creating an instance of this object. Let's say CO1 is new. We're going to call the new operator, creating objects, right? And then if I do a sysout, let's do a sysout co1 dot, and then this field, example class C6. And this is going to print null for us, which means C6, which was a field of co1 class or object, was initialized to null, right? So fields are going to be initialized to the default values when somebody creates an instance. If it's a static field, it will be default init. So if I say even before creating an instance, so a static C7, a static field will be initialized even before we create an instance, before creating an object. So because a static variables or the state of the object of a class that is static, it's part of the class. It doesn't rely on any instance. That therefore, whenever the JVM loads the definition of this class into memory, which means whenever JVM loads the class file, so when JVM loads the class file, so there is a class file somewhere in the package hierarchy, creating objects.class. When JVM loads the class file into memory, it immediately initializes the static state. So it initializes the static state of the class, because a static state has nothing to do with the instances. Even before calling the constructor to create an object of this type, the static state of the class has to be initialized. So here I can just say sysout, and the way we access the static of the state without creating an instance, we just use the class name .c7. If I run this is also going to print null, which means C7 was initialized to null. I didn't initialize it explicitly, but it will be initialized to whatever default value is for this variable, and the default variable is a reference type, and the default basically the type of these variables are reference and a static, and then the default value for a reference or pointer type is null, right? So that's what you should have in mind. So instantiating a class, the new operator instantiates a class by allocating memory for a new object. So that happens at the first step, and returning a reference to that memory. The new operator also invokes the object constructor to initialize. So you allocate memory, and then you have to basically fill that memory with whatever the value of the state of the object is, that particular instance, based on the parameters or arguments that are passed to constructor. Note, the phrase instantiating a class means the same thing as creating an object. When you create an object, you are creating an instance of a class, therefore instantiating a class. The new operator requires a single postfix argument, a call to a constructor. And we said that you are supposed to always use the fully qualified name, not only on the left hand side which defines the type of the variable that you're assigning the object reference to it, but even before that, because of the assignment operator, the right hand side has to be evaluated first. So you are supposed to tell the JVM what the type is that you want to create an instance of. And whenever you're talking to JVM about a type, it means fully qualified name. JVM only understands fully qualified name, right? And because it becomes annoying for the developers, we are allowed to use imports, right? But again, in reality, after the new, you have to tell the JVM the fully qualified name of the type. And then the round brackets are necessary so that you tell the JVM which compiler to call, which constructor to call. The name of the constructor provides the name of the class to instantiate, right? Again, this is not strictly correct. The name of the constructor doesn't mean anything. You're not specifying the name of the constructor. You're specifying the name of the type after the new operator, so that JVM knows which type to create an instance of. And then after that, the round brackets and the number of arguments tell the JVM which constructor to call. All right. So it's not the name of the constructor. It doesn't have anything. Doesn't have any meaning. It's the name of the type, which means fully qualified name. The new operator returns a reference to the object it created. This reference is usually assigned to a variable of the appropriate type, like this one. Later on, when we look at the polymorphism, we see that polymorphism works here. If you create a subtype, you can assign it to a variable which has a type of the superclass. The reference returned by the new operator does not have to be assigned to a variable. It can also be used directly in an expression. So you can create a new object, this new, and then the type and the round brackets. It creates an object, and it's equivalent to returning a reference to that object. And now that we have a reference to the object, this new variable, then you can directly call, for example, some dot operator, get a field, get the state of that object. Now, the problem here is that this new, we've seen this before, this creates a temporary object. After this line executes, we don't have access to, we don't have a reference to that object again, right? Which means now we have lost access to that object on the Java heap. We can never address it, which means now after this line executes, this object becomes a garbage in the memory because we don't have any access. So to make it more clear, so when we say, let's say we call a method system out print line, and we create an object in place, new, for example, example class, right? This is still a valid statement, but the thing here is that because we're not assigning this the object the reference that this new operator, this statement returns, it means that this is treated as a temporary object, which means we allocated it, and then after that we did something, but we never tried to get a variable that always points to this object in the memory. Therefore, after this line executes, this we can never reach out to this object again, which means the state of this object becomes a garbage in the memory, right? So here we are creating it's called a temporary object, because if you don't hold a reference to that object on the stack frame, you are never allowed to you can never point to it again. You can never reach out and grab the data that this object holds. So it's a garbage, right? If nobody can address it, therefore it becomes a garbage. This statement will be discussed in the next section, right? So this also works. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.